Let's take a look at this homework problem number 7 from 4A. And you had to sketch a couple of graphs and then find the intersection points. So, and then you have to do it algebraically. So first we'll just sketch the graphs. So y equals 2 root x is really, if we start with the parent, it's 0, 0, 1, 1, 4, 2. If we want to go one extra, 9, 3. And then to turn it into y equals 2 root x, we're going to vertically stretch by 2, which means multiply the y's by 2. So the x's don't change, but the y's all get doubled. So 2 root x looks like 0, 0, and then 1 comma 2, and then 4, 4, and then 9, 6. So here is that graph. And then we also have to graph y equals x minus 3. So I'll use a different color for that one. So for that, if we make a little chart, we could pick a few different points. 0, 1, 2, 3. If I plug them in, we've got negative 3, negative 2, negative 1, and 0. You could also do it by y-intercept is negative 3 and the slope is 1. So you go up 1 over 1. But anyway, 0, negative 3, and then 1, negative 2, 2, negative 1, 3, 0. So this thing is just going to be a straight line going through all these points. So let me get the ruler here and draw in that thing, if I can figure out where it is. Ruler, right here. And we'll get it lined up just right. And so this is kind of like, I think it was number 2 on this handout where we were doing something similar. You have to try and figure out where they intersect, and it looks like they intersect one time right here, and that looks like it might be 9, 6. So I'm going to guess it's 9, 6 for right now. What we want to do is prove it. Oh, let me label my line here. By solving this equation. So the way that we solve the equation, it's really like solving a system, right? Y equals 2 root x, y equals x minus 3. And we're solving for the intersection point, which is solving a system of equations. So we can use substitution. 2 root x equals x minus 3, which is exactly what the problem tells us to do. Now you have a couple choices. You can divide the 2 over before you square both sides, or you can just square both sides right away. The root x term is isolated over here. So if we square both sides, then this side will turn into 4x, because you got to square the 2 also. And this side turns into x minus 3 times x minus 3. So just make sure you actually FOIL that stuff out. So it turns into x squared, that's the first 2, then minus 3x, then minus another 3x, and then plus 9. So now when I simplify everything, if I subtract the 4x over, I'm going to get 0 equals x squared minus 6x minus another 4x is minus 10x plus 9. And then this thing you could use quadratic formula. You could factor by grouping. So let's do that one. Split the middle. So if we multiply to AC, that's 1 times 9. And it's got to add to B, which is negative 10. So let's see. Two numbers to do that would be negative 9 and negative 1. So then we're going to get 0 equals, and we use these guys to split the middle term. So instead of negative 10x, it's now negative 9x minus 1x plus 9. And then I can factor by grouping. So the x comes out of the first 2. A negative 1 comes out of the last 2. And we get x minus 1, x minus 9 equals 0 here. So now we use the zero product property. So x minus 1 is 0 or x minus 9 is 0. So x is either 1 or x is 9. And then we plug in and we check. So if we plug in 1 into both equations, now this is one where we want to check both. Okay, if you plug it into the first one, and the reason we got to check both is because we're squaring something that's got an x term in it. We're multiplying by x terms here when we square both of these. So we could create extraneous solutions. So when I plug in the 1, I get 2 root 1 for one of them, which is 2. And the other one I get x minus 3, 1 minus 3, which is negative 2, right? These are the two different y's that we were graphing and working with. So these aren't the same. These are not equal. So this x equals 1 is extraneous. Over here, when I got x equals 9, if I plug that in, y is going to be 2 root 9, which is 2 times 3, which is 6. And if we plug it into the other one, it's going to be 9 minus 3, x minus 3, which is still 6. These check out. So then I know that one of the intersection points here is 9, 6. And in fact, it's the only intersection point. Okay, let's take a look at 8 while we're here. So what is the image of a point, A, 4, 1, which is graphed right here, after it's reflected in different ways? So one of the ways is reflected across the x-axis. So here's the x-axis right here, right? And if you reflect across it, then you're going to end up at 4, negative 1, right there. So 4, negative 1. When you reflect across the y-axis, well, that's going to bounce it way over here, right? And since it was 4 units away from the y-axis, we got to go another 4 units away. And so this is going to be at negative 4. But this time the x value, the y value never changed. Okay. All right. And if you kind of look at it, when you reflect across the x-axis, notice the y's just switch sign. When you reflect across the y-axis, the x's switch sign. Okay. The next thing is reflect across the line x equals 7, which is here. Here's x equals 7. So if I reflect this across this line, x equals 7, well, I'm 3 units away because 4 to 7 is 3. So I got to go another 3 units this way, and I will end up 3 units from 7 gets me to 10. So that point's going to be 10, 1. And then there's one other one. This is a new idea right here. Reflecting across the line y equals x. So let me get rid of this. So the line y equals x looks like this right here. And to reflect across that, you might remember that's really related to an inverse. So this is related to inverses. And you might remember that when if you reflect something across that line, y equals x, you're finding an inverse. And another way to find an inverse is just to switch the x's and y's, right? So if 4, 1 is the original, then when you reflect it across that line, it just turns into 1, 4. So, and if we plot it, you can kind of see it over here, 1, 4. So if I go straight over to that line and just keep going by the same amount, that's where you end up. Okay.